So now, today we are discussing few critical thinking problems. So problem number 1 is a wire has non-uniform cross-section but uniform material. In which region is the drift velocity of electrons is maximum and why? So for this problem, we have to think like this, that I current is given by NEAVD, where Vd is the drift velocity. Current in this case is constant. So drift velocity is inversely proportional to area of cross section. Hence drift velocity will be maximum in the thinner portion of the wire. Now the second problem is on battery logic. Two cells of same EMF but different internal resistance are connected in parallel to an external load. Which cell supplies more current and why? Here we have to use the concept that as EMF for both the cells is same, hence current will depend upon the internal resistance. More the value of internal resistance, less will be the current. So here, cell with smaller internal resistance will provide more current. Now we will discuss problem that is thinking beyond formula. Problem is like this. A magnet is dropped through a vertical copper pipe and falls slowly. Why does it not violate the law of conservation of energy? Now in this problem, we think like this, that as magnet is dropped into the vertical copper pipe, then magnetic flux linked within copper pipe will change, due to which induced EMF is set up, and this induced current will oppose the motion of the magnet. So in this case, mechanical energy is converted into electrical energy as well as heat energy. Hence, law of conservation of energy is conserved. Now the next problem is two monochromatic lights of different wavelengths produce the same fringe width in Young's experiment. What can you infer about the experimental setup? Now in this problem, we will think it like this, that fringe width is equal to lambda, directly proportional to wavelength, and this fringe width is directly proportional to capital D, that is distance of the sources from the screen, and it is inversely proportional to distance between the two sources. Now as for the two setups, we are taking that wavelength is different, lambda 1 and lambda 2. So accordingly, we have to change distance of the sources from the screen as well as distance between the two sources so that fringe width remains the same. So we have to change the experimental setup. Now the next problem is, if light has momentum but no mass, how can it exert pressure? So now in this problem, the question is that light has momentum but no mass, because we are taking light in the form of the radiation. So in this case, P momentum is equal to energy divided by C, that is velocity of light in vacuum. So momentum depends upon energy and not upon mass. Light transfers momentum when absorbed or reflected, thus radiation pressure exists.